Right, let's just go further with this one. I'm going to work in triangle PGS and triangle FRS. And let's see how we can put all this information together now. Let's get all our theory on the one side. Great, I'm just going to scoot it over here. Okay, I got it all together now. Right, let's fire away. So, in triangle PGS and triangle FRS, I'm going to make three statements. I'm going to state the fact that PS is equal to SR. Okay, so PS is in this triangle right here. PS. SR is equal to is in this triangle here. And I'm going to make the statement based on the sides that are equal in length, properties of a square. So properties of square, the square that's been given is PQRS. Properties of square, PQRS, allows us to then say that PS is equal to SR. Okay, then I'm going to say I have two angles. So there's a 90-degree angle at S1 and 2 together, and there's a 90-degree angle at R. So let's state that angle. Let's say angle PSR is equal to angle FRS, and that angle is equal to a 90-degree angle. And why can I make that statement? It's because properties of my square state that all angles are 90-degree angles, because I'm working with a square. Then let's look at that last bit of information that we can use. We've been given that G is the midpoint on SR and F is the midpoint on QR, which we looked at, and that means SG is then equal to GR, which is the base of my small triangle. So I'm going to color it in for you. SG is the base of triangle PGS. So let me get that onto my theory. SG is therefore equal to, and then the other part that I have is the fact that, let me color that one in, this triangle has the base of FR. So how am I now allowed to go straight to saying SG is equal to FR? Why am I allowed to make this statement? If you provide a valid reason, your statement will be correct. So let's go back to using what was given. If we use the fact that G is midpoint of SR and F is midpoint of QR, then with G and F midpoints on SR and QR, respectively, meaning in that order, it means that SG is equal to GR and QF equal to FR. SG is equal to GR and QF equal to FR. Why is that? It's because all sides of the square are equal. And if I go and say that that's in fact the midpoint, then surely that length that I have here is exactly the same length as what I have there, as what I have there, as what I have there, which proves that SG is in fact equal to FR. Now let's see what scenario I have here. As I've indicated last week, try and refine your work so that you can have an easy understanding of the result. You have a side. This is a side. You have an angle. And you have another side. Okay, we got to watch out now because we said this scenario is especially a tricky one because when we have a side, an angle, and a side, we have to work specifically with that scenario in congruency that uses the inclusive angle. Okay, so with your inclusive angle, you are working with side, angle, side. Is this angle inclusive? Let's blow it up and see. I've proven that this length is equal to this length. And I've proven that this is my 90-degree angle there. I've also proven that this length here is in fact equal to this length here, which makes and creates that beautiful proof called side angle side where the inclusive angle has been used. Therefore, triangle PGS is congruent. Now let's see. Angle P must be congruent to angle P is equal to, let's quickly see. We know that S and R are equal, right? So that means that if we're struggling to prove the order correctly, we can see that where the 90-degree lies, I need to have the corresponding letter. So S must be equal to R, which means R is the last letter of this one. And then I can use one of my lengths to help me. Here's GS or SG should be equal to FR or RF, depending, right? Which means, what do I need here with R? I need an F, which means the remaining letter is S, which now makes it very clear the angle on P has to be equal to the angle on S, which is the angle here equal to the angle there. And you've got congruency because of your side, angle, side, and that allows you to then state if those two triangles are in fact congruent there, it means that PG is also equal to SF as asked in number F. Because of triangles being congruent. Okay, congruency allows you to prove lengths are equal. I trust you guys are with me on that, color-coded and all of that. So if you have problem in seeing what is in fact congruent or not, it's best to look at color coding, blowing it up a little bit, drawing it a little bit bigger perhaps. And then you can see through all those little indications that you do in fact have congruency. Now let's look at number G. Number G looks slightly different. We do have two triangles here. And number G states that in this diagram, let's quickly see what we can do here. We have certain things that are already equal. So A1 is equal to C1. It's an angle. And angle F2 is equal to F3. Okay, indicated by dots. And the measure being the same gives us that if you were to measure the angle of A1 and measure the angle of C1, you would get the same degrees, the same measure, the same size. Now we need to prove that F1 plus angle F2 is equal to F3 plus F4. What we were given is that F2 is equal to F3. That's why I color coded it here in what we need to prove, so that you can see a part of what is on the left-hand side is already equal to a part of what's on the right-hand side. So let's see how we can go about that. Firstly, where is F1 and where is F4? F1 is here and F4 is there, which means what they are trying to ask me, what I need to try and prove, in fact, is that this angle is equal to that angle, okay? Which means I'm going to have to looking at this angle as a whole and looking at F3 plus F4 as a whole. So where do we start? If we know that we've already got A1 equal to C1, I'm going to always encourage that you use your theory that's been given in the order that it's been given, because it will help you prove what you need to prove. So when we look at our triangles, then we can start with, oh, sorry guys. We can perhaps see how to prove congruency in order to get that those two angles will then be equal.